Good evening, good afternoon, good morning. Let me just unplug the relay. Okay. That is charging that 12-volt battery there. One of those tiny little relays cost me about, I don't know, $half a dollar, if you're going to call it dollars, 50 pence. Yeah, costs nothing, but it's feedbacking and doing that. Not what today's about though, so this is part 2 of the pancake coil exploration, let's call it. Still with my tip 31, and just for consistency I'm keeping the 1K on there. I think it regulates the speed of the switching in some ways. If you really want to get into it, you can use a 2K pot potentiometer here instead, and then you can alter, I guess it's the frequency or the duty cycle of the, pardon me, there we go, of the transistor using the potentiometer. And if you really want to get into it, which is where we are now, you best use a PWM, pulse wave modulation, onto there, and that way you can really get some what's the word, harmonics, some resonance with these coils, because that's where things get interesting, when you start resonating the coils together. That's when you can get some interesting feedback. What's the word? Positive feedback loop is what we're looking for, isn't it? That's what we're looking for, positive feedback. But just for consistency, I'm just using a 1K resistor on the base of the tip 31. And last video, I just did a driver coil and 1 pickup coil straight on top. But today I'm going to do 1 driver coil and 2 pickup coils. And as you can imagine, there's a million ways to do this. So you've got driver coil, that's always going to be there. You could have 1 pickup on top, 1 pickup underneath, and take separate outs, rectify separate outs. Or use 1 rectifier and connect them at the rectifier and take that voltage. You have 1 on top, 1 on the bottom. You could have 2 on top, all go in the same way, all coils turn in the same direction. In the same direction. You could have 1 on top go in this direction and 1 on top go in the opposite direction. You flip it around, see what you get there, and then you can also do all that, and also, so you've got your driver coil, you can join the coils together through the middle, so you're actually not having 2 separate pickups, you're actually joining them together, joining the wires together, and just having 2 wires out. So I'll start off by making the, well actually, if you want to do it, you've got to start off with whatever coil you want on top. So, because this is the easiest way to do it. It's easier to add coils underneath as you go. It's not easy to add a coil on top of a coil because you have to disconnect everything and put it back together again. So before you start, you have to have an idea of what it is that you're actually making. All my coils are center tapped. The only difference with the driver is the driver coil center tap actually is where the power comes in. So I'll just put the center tap on this one. This is going to be one of the pickups. Put the center tap on. Okay, done. So now if you were just going to put that on top of the driver, then you've got your 2 outs. And that would be that, same as before. So what I'll do is I'll put the driver coil, same orientation, they're both turning whichever direction, but they're the same anyway at least. So you put your 2 middle wires from the bottom coil through the middle there, you see. And you have to do your center tap again because this is the driver. So I'm doing my center tap but with a 3 blocker so I can connect the power to the center tap of the driver. Hopefully it goes in. Good. So this is the center tap for the driving coil. So again, black wire, black wire on the inside, red wire on the outside, the 2 different wires. So that's the centre tap for the driver. Put another wire in the middle to add the power to it. Nice and easy. And make sure everything's connected properly. Okay, so the driving coil, which is underneath, has the centre tap connected, and the other outside line of the driver coil will go to the resistor at the base of the tip 31. So the question is like, why? Why do this? Like, I've got a stack of 13 of these coils, and I used to stack them on top of each other, and I used to get excited about the voltages I'd get out. You know, it'd be like 200-300 volts coming off. But if all you're interested in is increasing your voltage from a small voltage to a high voltage, you just get a transformer. I've got these, we've all seen these high voltage modules, you know, these are magical. These are absolutely magical, these things. I need to explore more of these because I have a feeling like these could be quite interesting. You're just like 1 volt in and 1,000 volts out, you know. So if you wanted to just increase voltage, this is not the reason why we're doing this. This is not the purpose of these coils. Yeah, I think they are just transformers in the end. You know, you've got your primary driver coil, and then you've got your secondaries. And if you put more secondaries on, you stack them up, you will get a higher voltage. But if all you wanted was higher voltage, that would be enough, wouldn't it? So I think with this coils, I'm more interested in resonance. The ability to resonate them is the benefit of the situation, is your ability to resonate the coils. Anyway, not what we're doing today. We're just going to connect 2 coils together. So we've got the driver coil, got the resistor on, the other end of the driver coil. This really gets complicated to see, isn't it? The other end of the driver coil connects to the middle pin of the transistor. Which again, I put the diagram up so you can see what it is. I always get confused between collector and emitter. I should just sit down and just bang it in my head, shouldn't I? Yeah, but I know. And then the other pin of the transistor is going to the negative out. So that's fine, that's sitting there. Good. What have we got now? What have we got left? We've got 1 wire coming from the inside of the first pickup and a wire from the outside. Now, like I say, you could just run it, you could plug it in, and you're going to get that LED lit up. If I put the power on there, I put the negative on there, and turn on the power, and get me LED. There's me LED going today. Which LED's been sacrificed today. Like I say, like same as yesterday, there's no difference which leg you put it on, because it's coming out AC. Shouldn't be any difference. Bad connection on this wire. Really? Are you making a difference depending on which leg I put you on? Did I just blow you up? Did something blow up? Something. Every flaming time this happens. So I've got the resistor on the base, we've got the power on the negative, the power on the plus. And then we should just be okay with the LED, I presume. You're going to do it for me today, LED? No? All the way around? No? Did my LED just die? Can't be, can it? Maybe that's a bad LED. One of those today, huh? You buy a bag of 100 LEDs and you think, nah, don't need 100 LEDs, do I? So you know what, I'm going to need another 100 LEDs before long. Check the temperature on the transistor. The transistor is not hot at all, which makes me think there's something wrong with my connections. Maybe the negative was touching the other pin of the transistor. Boom, 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 boom. Well, that's embarrassing, isn't it? Once again, completely fucked up. Everybody's connected, everybody's happy. What's your problem here? Is everybody happy? It's the world, isn't it? The transistor shouldn't get hot, but you know it's working by your transistor being a little bit warm. There we go. That's made something happen. I think. One more try. It's just so bizarre it works for like a, there we go. So bizarre it works for like a second and then it doesn't work. So you're getting your LED lit, no problem there. I think I need to put a pickup on the negative wire because my negative out of my transistor. Because it's a bit short and I don't want to, if you want, you know, once you've got it working, you don't want to move things around because when you move things around, that's when wires get disconnected. And it's a ball ache to find that one wire that's disconnected. So anyway, look at power out, power in. There we go, okay. Power out, power in. Hopefully everything else stays happy. Double check. Everything's connected, so you've got your LEDs comes on. Bam, bam, bam. Good. Disconnect the power. So I've got one pickup coil on top, driver in the middle, and then if you want to put another one on, just stack them on. Put another one through. So this is where you get to that question of, okay, what's next? First off, center tap it. Always center tap. Put the red and the black. So put my center tap on. No problem. And again, you know, blooming boring as hell. I know it's boring, but somebody out there might be a little bit interested in something like this. And to go over the basics, and then once you go over the basics, once you understand the basics, then you can start going crazy. You can really start thinking about how to connect these things up. So many different orientations. So I've got my outs from the center of the two coils, one on top, one on the bottom, and I've got my outs. What's that? That's my negative out, isn't it? And I've got my outs from the outsides over here. Sorry. Okay. And again, just to double check, I'm actually picking up power. I'll take my out from one and the out from the other. Make sure it's the right out. This one. Funny. Oh, I mean, bleh. And you can put the power in like an absolute something. There we go. So put the power on. So I just put another coil on the bottom. So just to double check, the bottom coil is doing what it's supposed to be doing. I'll take an out from the bottom and another out from the bottom, which I seem to have just attached to the power. Which I seem to have just attached to the power out. Anyway, out from the bottom and out from the bottom. Is that the out from the bottom? Yeah. It's just the out from the bottom? Yeah. So why is it not lighting up? There we go. Okay. Just my bad connection. So the bottom coil's working and the top coil also working. So then the question would be is what do you do now? If you connect them in series, is it going to increase the power? What's going to happen basically? So what shall I do? I suppose I want to rectify the output from the top coil just to get an idea of a DC voltage out. Open source. Let's have open source. Open circuit. So if I suppose I don't need to do that. Yeah, because I need to attach the rectifier, don't I? So I'm gonna just, because I tried to avoid all these blooming crocodile clips. I could put them on, just do it with crocodile clips. That's obviously a lot faster, but it just gets so complicated with so many crocodile clips. Okay, so top coil, I've got my AC coming out, like the LED, but you couldn't do anything else with it. So then I'm taking my rectifier, which is just wound up diodes, and I'm putting the 2 outs onto the AC side of the rectifier. I put crocodile clips on my voltmeter. So it's 3.5 volts in, and the out is probably going to be about the same, I guess. So let's just see. Put it on. Oh, it can't be, can it? It can't be. Can it? Can't be, can it? Can't be 58 volts, can it? Just one coil on top, 58 volts. Let me just turn the power off. Make sure it's not my meter just being fucking crazy. Even when I turn the power off, I get 3 volts. If I unplug it from the wall, then I get 0, yeah? If I plug it in the wall, I'm still getting 3 volts. The power supply is not on, but I think it's the negative. The wires are different here, so I think there's still power coming through. If I put a LED across, that way around, the LED is going to take it down to 0.9, so it's not. Yeah, that's what you've got to be careful with as well in these places. You're like, whoa, it's working, free energy. Free energy, got my free 3 volts, but when I unplug it from the wall, 0. Anyway, turn the power back on. 57 volts just from one coil on top of another one, which is amazing, really. I think the magic thing about these coils, not magic, but the great thing about these kind of coils is their ability to turn the electrical energy into magnetic energy. I think they're very efficient at that. Very efficient at that. So almost like all of the energy is turning into magnetic energy and then being picked up by the second coil. Anyway, top coil rectified out, 58 volts. Okay, let's do the same with the bottom coil, just for consistency's sake, and see what is just off the bottom coil. See if there's any difference. Turn the meter. Leave the meter on. See if there's any difference from the top coil and the bottom coil. 58 volts. You can't complain with 58 volts, can you? I mean, not much you can do with it though, because my cap dumps are all running on these spark gaps, and that's a 75 volt, 80 volt, 90 volt spark gap. So for you to be able to charge something with the spark, it needs to be at least, I'd say, 100 volts for that to work. Yeah, these are, sorry, there's another one. So you take the in and it charges the cap, and then once it reaches that, that's the positive, that's the negative, it pops the cap out through the spark gap. But you need to be over 100 volts. Anyway, where's my other rectifier? Or do I have to undo the other one? Where's my other one? Is it in here? Not in here. Okay, I'll just undo it. I will undo. I'll undo this one. I'll put it onto the other one and see how the voltage is different. What was that? It just gets confusing. Was that the top coil I just did then? Yeah. So now we're doing the bottom coil. Yeah. Now we're doing the bottom coil to test 58 volts on the top coil, and the bottom coil is coming out at 59, 58 volts. I've got to find that blooming rectifier, don't I, so I can do this like straight up quickly. I'll have to make a new one. I have to make a new one. just so I can be 100% certain that's what I'm looking at. I haven't just put the wires on the same one again, have I? So if you haven't seen this done before, you take your four diodes, you get them pointing the same direction and you twist it off. That's your positive out. Yeah, same direction, twist it, positive out. And I suppose you could do the same the other way. You put your negative out, so here you're going to twist your negatives together on this side. Pardon me. So again, so in this one you've got the black lines pointing out, and then you just join them together, and that gives you your AC legs from where to attach what you want to attach. These videos are long, aren't they? It's my wife's mother's birthday, so they've gone out for the day, so just hanging out here. So again, this one 59 volts, and I'll put this one in and check the voltage straight up so I don't get confused with what I'm looking at. Put my rectifier on this one, so I've got my negative and my positive. Of course, and that's saying 72 volts now. So let's double check what I'm doing here. So this is the top coil, 72 volts. And of course, we've got the driver, and then you've got the other coil on top. I would imagine because of the same orientation, that's going to be the way it is. Because you've got the other coil is underneath, you know, I imagine, I don't know why, but I imagine the other coil underneath 59 volts. Because it's underneath, we'll push them down. Because it's underneath, I assume the driver coil is putting out an opposite electric field, north and south. Don't know which one's which, but the two top ones are aligned. The bottom one, I assume, is not the right way. So you would assume that if you turn the bottom one upside down, we will see if that has any effect on it. So that's what I'm going to do now. So right now the bottom one is reading 60 volts. And the top one is reading 72 volts, which is no reason why that should be the way it is. Because they're both identical coils, they're all identical. There's no reason, unless it's the rectifier is different, but I'm not going to mess with that right now. So quickly, no problem, easy, quick. I'm going to flip that bottom coil upside down and see how it affects things. So I'm going to take the center tap off, take the coil out, take the wires out, come on Mr. Wires, okay. Flip it upside down, put it back in again, take the two wires out through the middle, no problem. So I should check the temperature on the transistor. Transistor's getting a bit hot. Turn that off for a minute. Turn the transistor off for a minute. So now the bottom coil is upside down, and I'm going to connect the center tap again for the bottom coil. Double check, good. But then, you know, if you do the opposites like that, what actually might happen is they might just cancel each other out because they're opposite waveforms. They're out of phase by maybe 180 degrees, and then so you end up with nothing coming out of them, which is interesting. So put the rectifier back on to the bottom coil. Rectifier back on to the bottom coil. What do you think is going to happen? What do you think the voltage of this bottom coil is going to be now? Let's just double check the voltage of the top coil, which was 70, but because I flipped the bottom coil around, it might have an effect on the output here as well. Now the top coil has gone to 4.5 volts. How amazing is that? Okay, so just by flipping the bottom coil around, the top coil has gone from 70 volts to 4.5 volts. Okay, and now I put the crocodile clips on the bottom coil. 2.8, 3 volts. Hang on, I've not even got the power supply on. So bloody stupid. So stupid. Turn the power supply on now. Ging. Good. So I'm still getting 2.7 volts on the bottom coil. Let's see what the top coil is saying. 3 volts. I don't know how my wires are wiggling around. Make sure it's not touching it. It should be touching. 2.8 volts on the bottom coil. And the top coil. 4.6 volts. So you see how much of a difference that makes. If I disconnect the bottom coil, so where's the bottom coil center tap? That's the bottom coil center tap. Watch what happens to the voltage when I disconnect the bottom coil center tap. Look at that. Now we're in a whole different world, aren't we? Don't check my voltage. Whole different world now. So I've just disconnected the bottom coil center tap, and now the voltage has gone up to 145. And so you realise that that is about double what it was before, isn't it? That's double the previous voltage. So one more time. So how has the bottom coil doubled the top coil's output? There must be some kind of reflection going on from the top to the bottom. The top is reflecting off the bottom, and it's doubled the voltage. I'll do it again. So bottom coil center tap connected, 4.7, 4.6 volts. Disconnected, 144 volts. Okay, going to flip the bottom coil around just to show you it's double, 144. Take the rectifier off the bottom coil. So in some ways you don't even need to connect, don't even worry about the bottom coil. The bottom coil is actually just there as a mirror for the top coil. So that's what I've done, isn't it? I flipped it around so it's a mirror from the top. Pull the bottom coil out. Okay, pull the bottom coil out. Oh, flipping heck. Still 144 volts. Oh, the world. The world, eh? Anybody understand why that's gone to 144 volts just like that? Trying to understand these things is just so bloody difficult. Take the coil off. Connect it again. 144 volts, just one coil, straight up 144 volts. That seems amazing. And I don't know if it's just resonance though. Maybe I've set the resonance going then, but unplug everything from the wall, get all of them to 0. This is where resonance becomes so confusing, because you had it going, you turned it on, and there was no resonance. Once you started resonating, it changes everything, doesn't it? 4.5 volts, turn it on. Boom. Still 144 volts. No explanation. No explanation. I have no explanation. Put the coil back underneath. Now the coil underneath is going the same way as the previous coil. Connect the center tap. See how it affects the voltage. It went up, didn't it? Oh, I'm so confused. I'm so confused. I have to watch this video again to try and understand what's going on. The only thing that could possibly be going on in my mind, what's happening, is the transistor is becoming hotter or cooler or something. And it's changing it. But I mean, look at that, 146 volts of one coil. It's interesting. It's very interesting to me. And that's not even with the outs from the second coil. So if I do just touch the outs from the second coil, I can find the wires. I can literally, like, it's just wires. Why can't you see the wires? If I can take the outs from the second coil, there's one. Where's the inner one? Is that that? Okay. If I just touch them onto the rectifier, if I can, I'm going to have to use a clip. I'm going to have to use my clips. Okay. Put one on that side. One on that side and then just connect them to the second coil. So now both coils are going through the same rectifier. See if it makes any difference to the wave coming out. So it's gone down a little bit. If I flip those two round, look at that. So that's cancelled out completely, back down to 2.7 volts. Cancelled it out completely. So obviously what I've done there is I've connected to the two coils opposing each other, and I suspect that is, this is so strange. Power off, 4 volts, power on, 2.6 volts, power off, 4 volts, power on, 2.6 volts. Why would the turning the power off make the voltage go higher? No clue. And let's play the game of putting on the ground as well and see how the ground affects the output as well. Put the ground onto the negative side. Put the ground on. Takes it even lower. Put the ground on a different leg. 24 volts when I put the ground onto that side of the AC. 24 volts, I put the ground to that side of the AC, put the ground onto the positive, 0. Isn't it amazing? It's just, basically, the point is there's so many different ways to do this. I haven't even connected the two coils the way I would normally, but just to give you an idea, it is complicated. It is a lot of garble, garble, garble. But finding the right orientation and then also using capacitors to add that resonance between the coils. And what was I thinking? This is basically what I thought the other day was, is we're always trying to loop it, trying to loop the output back to the input, try and get over unity, whatever you want to call it. But I've realised that's not what you want. What you actually want is you want the input to be resonating with it. So there's no, from the output to the input needs to be resonating as well. So I figure no matter what, I'm going to have a capacitor across my input. Let's just see what happens if I put the capacitor across the input now. Put capacitor across the input. Not much difference, but you have to have that capacitor across the input to enable it to resonate, the input to resonate with the output. Also, what if I put the capacitor across the output of the coil? I'll just flip it in there. No change. And across the AC. Put that 0. Put the capacitor across the AC. 0. Amazing. So anyway, it's interesting to play with, lots of things to do. This video has been far too long. But just to show how we connect the two coils on either side of the main coil and the possibility of opposing and how to connect them as well. And even I want to start looking at connecting them in parallel. So connecting all the outside wires together and the inside wires together, rather than connecting them in series where you go from the outside to the inside, outside to the inside. More experiments to do anyway. Have a good one. I'm going to have a cup of coffee to make.